need the table because we're using that. Yes, we'll be using it too. Just from the at the beginning side. Please look for it. It's there. Okay. Please, I need you guys to call the question. Call it out. So I can just do my free body diagram. Okay. Yeah, who is calling the question out? Please, someone should help out with the question. Yes. Yes. It's very blue. Ah. Feeling not blue. Okay. Discuss. No, no, no. 3B, please. Discuss his theory. Okay. Twelve meters by 22 meters. 12 meters by 22 meters. I'm coming. Sorry. Come. Come. Let me draw this well. So this is the top view of our the top view of our RAT foundation. Don't forget I mentioned that when we are dealing with RAT foundation, it's basically this is look like a square, but it must be rectangular. Yeah. So RAT foundation is rectangular. So and they said we like along the question towards the end you see something about getting it at the center. And when we are doing vertical stresses, when it came to stresses at the center or at any point in a foundation, we have a particular formula that is change in stress is equal to IQ small letter q IQ naught times 4 for a rectangular foundation at the center. Then at any point is just basically dividing the rectangle into different rectangle, 4 rectangles. So now we have 1, 2, 3, 4. For this one, we're looking for it at the center. That is our vertical stress. Change the vertical stress will be equal to 4 Q naught I. Yes. So this is the formula. Why is it 4 Q naught I? Because of they have equal rectangles. Yes. So let me just draw this better. Wait, this will be 6. Yeah? If it's not equal, at a point that is just a you should divide them into different rectangles. Then you get the length and breadth for each rectangle. So from that the M and N will be different. That is your influence factors will be different as well. But this one because they are equal, that's why your influence factors are equal and you are just multiplying by 4. Yes. So this is 11 meters by 11 meters, 6 meters, 6 meters. You guys get how I got this now? That's divided by 2. It's a rectangle. So now please call the question well, please. Okay. Wait, please. After that, wait. Let me show you guys. So now all these diagrams are very, very important. I remember him even mentioning it in class. And it's not just about drawing this, it's about labeling correctly. Because he said drawing this without labeling, you've drawn nothing. So now we are meant to have GL here, GL here. Wait. Drawing this is important when you want to when you want to do your calculations. And drawing this because in the class before this week or this week, I forgot in the class, he said something about labeling. Yes, so he said drawing this is not enough. And it wasn't this settlement. Yeah, that's true. So settlement wasn't complaining. He was saying drawing this is not enough. That adding, like for now, this is ground level. If you don't put this GL, we will not know what this is. So you've lost some marks. He said it in class. So now this is what again? 150 kilonewtons per meter square. You guys should just follow this because you need this. Then what again? Oh, I should have left space. So I should have left space. Sorry. Okay. below this is the ground surface. So the depth of the foundation is 2 meters. Then medium dense sand below 8 meters, 8 meters thick. So from here to here now is our 8 meters. So that's where you find your sand layer, 8 meters thick. That is from the base now. So it's from the base now to the base of the sand layer is 6 meters. Okay. Clay. Shea clay? Stratum of clay. 4 meters thick. So your clay layer now is 4 meters thick. So this is clay. Yeah. Okay, that one we can just leave it off. That means it's continuous, but this is what we want to use. Yeah. And that thing I should take note. Below ground surface, groundwater table. So just maybe a dotted line or anything to indicate your groundwater table. This is how to indicate your groundwater table. Yes. And it is 2 meters below the ground surface. Yes, okay. Sorry. The odometer, this thing, the values gotten from the lab test. You know what? That part, skip it. I will explain that part later. Go to uh-huh. Okay, that part too. Skip it in a way. Yes. Mm-hmm. Okay. Let me put that here. So under this clay layer now, you have saturated unit weight of clay is equal to what? 18.3 kilonewtons per meter cube. Moisture content 30%. Yes. 2.68. Sand above. So yeah, sand above water table between this place. Yeah, what do we have? 2.65, 12%, 30%. That was for below the water table. So between here now, our normal start is equal to 18.0 kilonewtons per meter cube. Okay, for now, we will talk about the question later. Now let's get some things before we start now. Okay, yeah, read the question, read the question. He's not around. Okay. Okay. Let's continue then. So, what? Read the question. They're on their way. Yes, sir. Ah. You continue. Read the question. Mm-hmm. Mm-hmm. Yeah, that's what I want you to mention. So yes, that's another part I want you guys to take note of. So you're going to divide this clay layer into two finite part, 2 meters, 2 meters. Yes, it was stated in the question. So what you are going to be getting now is you are getting whatever you are getting for this layer and for this layer, for the two layers. You get. So now the first thing we should do here is to get, look at something. We need to get something. What are we getting? We need to get our our void ratio. Don't forget from the formula I gave you guys on how to calculate settlement. The first question is settlement, right? What is our formula for settlement? Settlement. Eh? What is that? MV delta stress H. So there'll be a table now. Don't forget I said that this is settlement from, did you write it? From the void ratio against pressure. Yes. So now we need to get that void ratio. We don't have any void ratio yet. But how can we get void ratio? Is by getting the effective stress and yes. We want to draw it first. Should I wait for you guys to draw it first? Then we go on. Okay. Are you following? Eh? Yeah, now I said our knowledge of soil mechanics, we need to bring it back. My phone, where is it? Come on, Lafe. Please, is that why I put it on top of something? Don't scratch the back. Oh, wait, see that pouch. I'm too far. I have Michael. Yes, ma'am. 2 meters, yeah. What I want to say that like this. This cannot be 2 meters, though. Wait, it's 2 meters. That means water table is here at the base. Oh, that's true. Thank you for that. Oh. Is in my bag. So that means this is, yeah. This is also, yeah. Should we just 18 now? Yeah. Because they just said this is 2 meters. The depth of the foundation is 2 meters. Eh? Moisture content, yes. Moisture content. Eh? That's how they give it to us, yes. Porosity. N is porosity. Eh? It's not my bag. It's not there. I left it at home actually. I did. Okay, are you guys done? Almost. Please, let's be fast. There is no time. Sorry. Mm. So this all thing is sand layer. Yes. Eh? Mm-hmm. The depth of the foundation is 2 meters. Oh, sorry. 2 meters. Which two? Okay, forget. Okay, sorry. Just leave it. They just reminded me that the water table is at 2 meters, and also the depth of the foundation is also 2 meters. That is, the water table is at the base of the foundation. Yes. So can we just move on, please? Can we move on? You can. Okay. This is what we are looking for. Now, from our knowledge in soil mechanics, what is our void ratio with these things we have? The first thing first is the first thing we have to get now is we have to get the unit weight. We have to use we have to get the total unit weight of this whole thing, because we first, like I mentioned now, we are doing this first. we are doing this layer first, then this layer. So now from here to here, we have to get the total unit weight acting on this to get the total this thing, the total effective pressure. And to get the effective pressure, it is unit weight times the depth at that particular point. So for us to get this now, from your effective pressure calculation, you will do this, the unit weight of this layer times the depth plus the unit weight of this layer times the depth plus the unit weight of this layer times the depth. Yes, thank you. But now for these three, when I was teaching you guys vertical stresses, I mentioned that when we have something like this, for the clay layer, we are going to divide it into two again.